According to somebody on the news, the real proportion of heads with a fair coin is 0.73. You wanted to test this, so you found 46 coins and flipped them off, all at once, off the top of a building. You witnessed 30 heads test at 5%. First, consider what is the parameter. What is the parameter? Well, here the parameter is the true proportion of heads. What is it we want to test? Well, we want to test something about that parameter. We want to test the quality of the idea that it is 73%. That's the value that's on trial here. And how many tails? Now this is not a pun. This is saying how many tails do we want in our test, because we can have two tails or one tail. So let's try all two-tailed tests. All right, so we're trying to demonstrate here that the alternative hypothesis is true. So we got to calculate our test statistic. What we need to do is use our sample statistic. And we're going to use that sample statistic to test. So all we want to know is how far away is 30 out of 46 from 73%? Is it far enough away for us to establish statistical significance? And when you compute it, the test statistic, you get negative 1.20. Negative 1.20. Now let's calculate the p-value. So we just want to find out if the null hypothesis is true, what is the probability of finding evidence as extreme or more extreme than what we just found? So we can calculate the p-value by looking up on the standard normal distribution, negative 1.2, and then we have to multiply by 2 because we have a two-tailed test, and that gives us a p-value of 0.2301. Now, what if instead you decided you wanted to conduct a one-tail hypothesis test? So let's look at the left-tailed test. Here what we're saying is we're just looking to test that the proportion, and p here doesn't stand for p-value, this stands for the true proportion, that's our parameter. We're just looking for evidence that we have less than 73%. So everything's basically going to be the same up until we get to the p-value. Here we have to make sure that we're not multiplying our probability by 2. We're just figuring out what the area is to the left of negative 1.20. That's how the p-value is defined. So this probability is just 0.1112. So those first two make some sense. The third one doesn't make any sense. Let's see why. Right-tailed test. That means we're basically trying to find the probability that what proportion is more than, not 50%, I should say 73%. With the right-tailed test here, we still have the same null hypothesis as before, but we're just trying to demonstrate that the true proportion is more than 73%. Everything's the same here, except when we get to the p-value, we get something that's totally absurd. We get this huge p-value. Now remember, we only reject the null hypothesis if our p-value is less than alpha.